All right, let's do some polygon work. So we're going to be classifying polygons. One of the things that you have to be familiar with is the prefixes of polygons. You know what tri means, 3. Do you know what quad means? I think most of you understand that quad means 4. Pentagon is your 5-sided figure. Do you know what hexagon stands for? Hex is for your 6-sided figure. Do you know your 7-sided figure? Unfortunately, the poor little 7-sided figure never gets used for very much, so most people don't know what a 7-sided figure is called, but it's called a heptagon. H-E-P-T. 8-sided, most of you got that down pat. That's an octagon, obviously. And then let's just go up to a 10-sided figure, which is a decagon. So you have your triangle, your quadrilateral, your pentagon, your hex for 6-agon, your heptagon for 7-sided, your octagon for 8-sided, and your decagon for 10-sided. So those are the polygons that you need to be most familiar with. And remember, a polygon definition is a 3 or more sided closed figure with line segments, no curves, no round edges. That's a polygon. We're going to learn to find the measures of the interior angles of all polygons using specific formulas. So let's get started. So first, classifying. So you're going to go and you're going to count how many sides we have. 1, 2, 3, 4, 5-sided figure. So what would you call that? 5 sides. Yep, it's called a pentagon. P-E-N-T represents 5. Count the sides on this. 1, 2, 3, 4, 5, 6, 7. 7-side, would we say a 7-sided figure is called? Poor little 7-sided figures never get used. It's called a heptagon. Okay? So that's standing for a 7-side. Here we got easy. 1, 2, 3, 4, 5, 6. 6-sided figures is your hexagon. And what are you going to call these pair of pants right here? Because if you look at these pair of pants, you got your little feet here, right there. A little pair of pants, got the little body going up here, little belly button, little arms coming off to the side. Yeah, what are you gonna call? Did you figure it out already? 1, 2, 3, 4, 5, 6, 7-sided. That's our little heptagon again. See, who'd have known your pants are really heptagons? So next time you put your pants on or your shorts on, you can say, I'm gonna go put my heptagons on. There you go. So now we're going to find the sum of the measures of the interior. This is really important. Inside the figure of a quadrilateral. Now, if you remember, we went over triangles. And remember, I said the sum of all the angles of a triangle are always equal to 180 degrees. So knowing that, if I built a quadrilateral, quad being 4, you have 2 triangles inside a quadrilateral. So knowing that, what's the sum of all the angles of a quadrilateral going to be? Think about it. Yep, 160 degrees. So now, if I give you the quadrilateral has 4 sides, you can easily figure that out, what the sum is going to be. So there's this formula that we use. Let me erase the screen here. That helps us figure it out. So we know that the number of sides minus 2 times 180 degrees will always give us the sum of the measures of any polygon that exists, okay? So if the number of sides, because it's quadrilateral, is 4, I'm just going to do 4 minus 2. Why? Because that tells me how many triangles we can build inside the figure. Remember what I just did? I drew the figure. I said, oh, how many triangles can I build in there? 2. So we learned that the formula, the number of sides minus 2, will always tell me how many triangles I can build inside of the polygon. And then a triangle is always 180. So you do this problem and you know the measurement of the sum of all the angles of a quadrilateral is always 360 degrees. So then we do it again, but let's do it with a pentagon. Same thing. So if you have a pentagon, you have to figure out how many triangles you can make into a pentagon. You're going to use the same formula. N minus 2 times 180 degrees. N being the number of sides. So 5 minus 2 tells me I can build 3 triangles. Try it. Inside of a pentagon. Every triangle is 180 degrees. And then I can clearly figure out that a pentagon, which is 3 times 180 degrees, is going to be 540 degrees. Okay, that's the sum of all the angles, okay? A stop sign is an octagon. So how many sides are on an octagon? Right, 8. But look at how the question changed. It says, what is the measure of 1? So if I go back, this says the measures of the interior angles. It doesn't say 1. It wants the sum of the measures of all of them. So now I want you to think about this. There's a key word and it's right here. Regular means all sides and angles are equal, or we say in geometry, congruent. They're all the same. So let's figure out how many triangles we can build into an octagon first. So first you're going to do n minus 2 to figure out how many triangles we can build inside times 180 degrees. So the sum of all of the angles inside is 1080 degrees. I want to know the measurement of one of the angles. If I told you that all 8 angles are exactly the same, how am I going to figure out the measurement of one? And how do I know they're exactly the same? Because it's a regular octagon. So I'm just going to take this number and divide it by 8 to find out the measurement of 1. So all 8 angles inside that octagon is going to be 135 degrees all the way around because it's a regular octagon. So you got to be really careful when you're reading these questions. If it says the sum, then you're just doing this formula right here. If it says the measurement of an interior angle or one interior angle, then you use this formula and then you have to divide it by the number of sides to figure out the measurement of one. And remember, in order for you to do that, it would have to be a regular octagon. Regular. Regular means all angles equal. There you go. Let's try it again. Picnic table in the park is a regular keyword. All sides, all angles equal. Hexagon, which is how many angles, how many sides are on a hexagon? Right, 6. So what is the measure of one interior angle? So again, you're doing n minus 2 times 180. That's going to give you the sum. Once you're done with that, you're going to divide it by n, because that's going to give you this measurement of one interior angle. So you're going to do 6 minus 2 times 180 divided by 6. So try that out. Hopefully you got 120 degrees. Yay. That's it. Pretty easy. So basically, just backing up one more time, the formula you're going to use to find the sum of the measures of all angles of any polygon is this formula. If I ask you to find one angle, then you're going to take that formula and you're going to divide it by the number of sides. But remember, it has to be regular. If it's not regular, you can't use the formula because that would mean that the angles are not all necessarily equal. Okay, good luck.